Please, is Mr. Black on this call?
No, he's not here yet. Please, can you drop the link for the so that we can? He has not posted it in the group yet. Please, sharp.
Is he on the call?
No, he's not. He's not on the phone yet.
Please, if you can message him, tell him I'm trying to log in stream on YouTube. So they're asking me to log back Gmail. So tell him to check for 94. My WhatsApp message is still loading, so I can't message him. Please message him, tell him to check on his phone. I don't know if it's his phone, it's a Galaxy, something. Tell him the phone to click on 94 so that I can get access to the Gmail to stream on it. Please. Yeah, thank you. So Baba, you are co-host now. So because I think I'm about to drop down from the bus that I'm in, so I will not be able to have I'll not be able to operate my laptop till I get home. That should be like in the next 10 minutes. So I think you have access to all the features except Gmail. If you can be able to log in the Gmail to stream on YouTube, that will be fine. Before I'll be able to have access to my laptop, it will be like 10 minutes.
Before you drop, did you message Mr. Black?
I'm trying to message him, but my WhatsApp messages are still loading, so I can't message him now. I even had to message him with another WhatsApp number. So that's why I say you should do that for me, since you get it faster. So yes, I'm trying to stream on YouTube, but they're asking me to verify the email again. And for me to do that, he has to verify it from his own end. He needs to click on a
All right,
number
so
on his
don't worry. I think he has done it. He has done it. I just see he just dropped it. He has done that already. Just
Oh,
all right.
okay.
Thank you.
That's not
Paid me for this before. But I don't know if you added my 1,000.
He just dropped all the links in the participant group. I think they will start joining now. So just
Oh,
but how manage? Why did we? Why were we so late today now?
oh, like 17. Nobody cares. Look at it. I'm not going to bring them on down.
Hello, good evening. Hello. Victor.
Hello, Prof.
Hello, good afternoon.
Hello.
Hello, good afternoon.
I'm here. Hello, Victor. Oh.
Moderator, Victor, you can start the class, please.
Are you hearing me now?
Yes, we can hear you, sir. Thank you. So let's start with the introduction. A very good evening to all of us. Good evening, our dear farmers.
I'll start now.
Hello, Prof, sir. Prof, sir, can you hear me? Hello, Prof, sir. Hello, Prof, sir. Hello? Please, Prof, if you can hear me, can you All right, so please, Mr. Black, if you can also hear me, can you please indicate? Let me be sure it's not just from my end.
Yeah, Victor, we can hear you, although you're low, your voice is low, but we can hear you. Can you speak a bit louder? Professor Jacob, we can see your video and we can hear you, but Victor will start the session. Welcome, Prof.
Okay.
All right. Thank you very much, Prof. You are welcome. And to our farmers,
Victor, your voice is low. Can you come out a bit louder? Your voice is low.
Okay, can you hear me louder now? Am I more audible? Am I better now?
Yes.
Okay, thank you very much. So a very good evening to everyone here. To our farmers, we are happy to have you here again. And today we are having Professor Jacob Wapa. He's a farmer whose education journey started as he earned his first school certificate in 1980, his BSc in 1995, his MSc in 2003, and his PhD in 2024. With over 20 years of lecturing experience.
Using a headset, your voice is very low.
It's not a headset, not at all.
But I can hear clearly now.
Oh, good. So Prof said he can hear me clearly.
Yes.
Okay, proceed, please.
All right, thank you.
I can proceed.
No, Prof. Let me go on with the introduction, sir. Let me go on with the introduction.
Okay.
Yes, sir. So, Prof here has over 20 years of lecturing experience, and like most of us, he has a long life experience as a farmer. He's a member of over 30 university, community, and public service organizations, member of the Soil Science Society of Nigeria, International Union of Soil Scientists, also a soil science member of the Soil Science Associate of Nigeria and the Nigeria Institute of Soil Science. His awards span from the Friends of Agriculture in Nigeria Award, FOAN in 2014, Fellowship Award by the Institute for Policy Management Development in 2019, also the Nigerian Patriots of Education Exemplary Award by the Majesty Global Charity Organization in 2019. Also, he also has an award, an Outstanding Personality Service Award by the African Most Prestigious Media Award, Africa Update International Magazine in 2020. Ladies and gentlemen, I can't read all through Prof's profile right now, but I am glad to tell you that he has over 35 publications, both on journal and conference paper. Ladies and gentlemen, with your digital hands and your comments on the session, let's welcome Professor Jacob Wapa of the University of Abuja from the Department of Soil Science. Prof, you can take it up from here, sir.
Thank you, Mr. Victor. And ladies and gentlemen, my listeners, you are welcome to this wonderful lecture. I want to do my all possible one of you happy. And as a practicing farmer, Victor has said already, I'm not only in the field of soil science, I'm a practicing farmer. In fact, right now, just a few minutes ago, I have to go and supervise the little I have planted. So we are talking this afternoon on safe soil management practices. Safe soil management practices. Before you can be successful in agriculture, you must use the soil. But soil is not only used by only farmers. And that's why the definition of soil is as many as the people who use them. Engineers can define soil in different form, farmers in different way, even petroleum explorers and then the rays can define soil depend on the way they're using. And so soil is an indispensable resource that we cannot, human being or man cannot do without it. But the problem is because of population multiplication and then the race, soil is being used poorly and inappropriately. And so inappropriate use of soil can cause damages and then even affect the farmer's yield. And that's why we are looking at this subject, safe soil management practices. That means if you want to sustain the soil to provide food for us and meet up the food safety for the country as a nation and then the world at large, then there must be practices that are safe, that can increase the productivity and sustain the soil fertility level. And that's why we are looking at these practices. So the practices are many, but for the purpose of this class, we are going to minimize to meet up our own need at a local level. So when we look at safe soil management practices, prioritize preserving the soil health and fertility when minimizing environmental impact. Misuse of soil or inappropriate use of soil can affect even the whole environment. When we talk of environment, including the atmosphere, including water, both the surface and on the groundwater, can be affected when soil is being poorly used. Then the key techniques that we can use to safeguard the soil, including what? Number one, proper conservation tillage. That is the type of tillage that we use on the soil that can conserve the fertility status, and the sustainability of the soil. Then the use of cover crop or cover cropping, then crop rotation, organic matter addition, and integrated nutrient and pest management. These are some of the practices that we can put on the soil, at least to sustain its productivity and fertility. And these practices can reduce what? Erosion, improve soil structure, and enhance overall soil health. So for clear understanding, we will discuss the topic under the following subtopics or subtitles. To understand more, we want to identify number one, soil contaminants. How do the contaminants affect the soil health? And then when we identify these contaminants, then we will mitigate, that is to reduce the effect of these contaminants on the soil. So identifying soil contaminants involves the following steps. Number one, site assessment. Before you can assess or identify that this soil is polluted or this soil is contaminated, then you have to identify the site. You have to assess the site. Then when you assess the site and identify the site, you have to sample this soil. The sampling can be either randomly or by using a design way of mapping the soil, and then you site the point through the use of GPS and then the rest. You sample the soil and analyze to identify pollutants that affect this soil. What are the pollutants? These are the contaminants. These contaminants, number one, can include heavy metals in the soil. Heavy metals, not all of them are useful to plants. We have essential heavy metals. We have non-essential. And even the essential, which are being used as micronutrients, if they reach toxic level, there's a level that when they reach, it can affect the soil properties as well as even the biota, that is the living organism in the soil. So we look at heavy metals. Then heavy metals can pollute the soil, can contaminate the soil if they are in excess. What are these heavy metals? Including lead, including copper, mercury, zinc, and a lot of them that we cannot all enumerate. Some of them are essential, some of them are non-essential. Then how about pesticides? Pesticides include insecticides and herbicides. These are called agrochemicals that are being applied on the soil, number one, for the purpose of controlling that is weeds, grasses, and then the rest of them. The use of herbicides today is all over. You go to the villages, you come to the city, all of them, at least people are using this pesticide. Apart from herbicides, then insecticide. For example, here in Abuja, you cannot cultivate cowpea without the use of pesticides. Why? Because of the pest infestation, particularly around that November, December. So, few years ago, before we even came here, people don't even plant cowpea, that is beans. Why? Because of this reason. But gradually, with the use of insecticides, people can cultivate all kinds of beans, that is cowpea, the red one, the brown one, the white one with black heads, and then the rest of them. And but you have to use this insecticide. If not, pests will render you just valueless, and at the long last, you cannot even achieve anything. How about hydrocarbons? hydrocarbons, we may say that, oh, we here in Abuja, we are not producing petroleum product. So our soil cannot be contaminated by hydrocarbons. Yes, but how about mechanical workshop everywhere? You go to Zuba, you go to everywhere. There are a lot of places. And these people, at least when we have been using the sample, we have been practicalizing and assessing the soil, that the soils rendered useless. Why? Because of the presence of either spent engine oils and even some of the fresh one by split and then the rest of them. So hydrocarbons, mostly they are being introduced into the soil through petroleum products. So these, when they are in the soil, either heavy metals, how can heavy metals reach? Heavy metals even through whatsoever. It's a mining, illegal mining everywhere, exposing the subsoil soil to the surface, thereby contaminating with all these heavy metals. How about even dump refuges everywhere? These refuse, they contain high quantity of heavy metals. And when you leave it for long, can contaminate the soil and then even the environment. So these are the, when we were able to identify them, the soil polluted, contaminated, is it by heavy metals? Is it by pesticides? Is it by hydrocarbons? Then what do we do? Next is to know how to reduce, that is mitigating what these contaminants can be achieved through various ways, either physical removal, either bioremediation, chemical treatment, or phytoremediation, with specific approach depending on the type of contamination and site conditions. So when we see this, then we have to do something at least to mitigate. The sampling, when we identify that this soil is contaminated, this soil is polluted, then, as we say, there are processes that we have to carry out on the soil, at least to mitigate these problems. The soil sampling. Soil sampling is being done, as I said earlier, either randomly from the contaminated sites, or you can use either diagonal. There's something we call composite sample. If the place is large and you cannot sample 1 to up to 10 or 20 samples, you can sample diagonally, either across the land, how many hectares of land. If it is 1 hectare, you can take about 10 samples, mix them together, and take a portion and take it to, this is what we call composite sample. About 10, 5, or up to 20, depend on the land. When you mix them together thoroughly, you can also do surface and subsurface soil. You sample from 0 to 20 or 30 centimeters, then from 30 to 50 centimeters. That is surface and subsurface for individual. But if for arable crops, like all these our cowpea, legumes, and even some of the cereals, their root cannot go beyond 30 centimeters. So you can only sample the surface. You sample the surface and then take it to the lab and then do soil testing. Soil testing is you have to undergo analysis, analyze this soil and look at the content of these contaminants. If it is heavy metals, then after you extract your solution with either DTPA, EDTA, or even diluted hydrochloric acid, then you take this supernatant solution and you take it to what we call AAS, that is atomic absorption spectrophotometer. That's the machine or the equipment we use to give you the number, the amount of every heavy metal in that soil. Then, if it is ordinary, you are looking at the pH, we use pH meter. If you want to know whether this soil, the texture is being affected, the structure is being affected, or you can do hydrometer test or particle size analysis to know whether the texture of the soil is being affected. Then from there, you have the result, you interpret this, your result. Okay, you have discovered that, okay, the level of these heavy metals are high, soil is polluted. Then what do we do? That's the next time. What do we do? When you discover through this analysis, your soil is contaminated, your soil is polluted with heavy level of heavy metals, or with pesticides, or with hydrocarbons, then what do we do? We do what we call remediation. How to correct it, how to reduce these contaminants. There are steps that we take. Number one, either physical removal or bioremediation, as we have mentioned it earlier, or the chemical, through the use of a chemical compound that can remove these contaminants. How do we remove contaminants from the soil physically? There's what we call in situ and ex situ treatment. In situ is that either you inject something that can hit the soil, you inject it into the soil, and then you hit it and demobilize or reduce or remove these chemicals, these contaminants. Then there's what we call ex situ. Ex situ is that you excavate and remove this contaminated soil, and then take it to a place that at least you can hit the soil. But actually, as Africans concerned, it is really not feasible. So the only thing is to excavate the soil, to remove the complete surface soil and take it to somewhere and replace with soil that has high organic matter content. That is physical. Physically, you can do that. But mostly if you have large hectares of land, mostly they are not feasible for all. The only thing is you do bioremediation. What is bioremediation? Bio is life, using life to correct the soil. Which kind of life? Either introducing microorganisms to break down these contaminants. You can introduce, and how can you introduce microorganisms? By even applying organic material, organic matter, organic manure. You know, this micro the breakdown. These microorganisms will eat these chemicals and break them down into simpler forms that cannot affect the soil properties. Then this method also is very suitable for certain contaminants and can be less disruptive than the physical. It is better. Apart from that, the use of chemical, you can use some of the chemicals that you can apply on the soil, at least to reduce. But these chemicals also, they are not fertilizers, but they are used to neutralize or immobilize the contaminants. What is immobilize? The soil is, the contaminants is there, but these chemicals can arrest the contaminant and immobilize them, they will not allow them to move from one place to other, and thereby reduce the level of contamination. Apart from that, even phytoremediation. Phytoremediation is the use of plants. There are certain species of plants that you can use, you can plant on a contaminated soil that can arrest this situation, either pollution by herbicides or agrochemicals generally, or contamination by hydrocarbons or even heavy metals. Let's be specific for ourselves here. At our local level, we can use banana and plantain locally, plant on a polluted soil. You can use it. These plants can be used to immobilize this contaminant. Because if we talk of some of these species which are not available in our own environment, but the one we have specifically, you can use banana and plantain plants. Plant in a polluted soil can press all these contaminants and save the soil. Then even soil stabilization, you can use it. And other methods, there are a lot of other methods that you can apply on the soil. As I said earlier, the use of organic material, particularly organic matter, specifically cow dung. Cow dung is a very stabilized and highly buffered organic material that can be used to correct either high pH, either low pH, and even contamination by heavy metals. Because what? When you apply cow dung, you apply organic manure, it will regenerate and multiply all microorganisms in the soil, which use these chemicals and can eat them and reduce them into simpler forms that will not be harmful to our plants. So you can also prevent. If you cannot correct all this, then there are ways we can even use to prevent this contamination. How can we prevent them? Because the English adage says, prevention is better than cure. So instead of us to look for other treatment, we can prevent it. We can prevent this contamination. How? Number one, by proper use or management of waste. Proper management of waste. Implement responsible waste disposal practices. This one, locally we can do it. But today in Nigeria, if you say somebody, okay, go and throw this dustbin, you give children, they will just go and dump it on a very fertile, very important soil, and thereby can contaminate. But proper, let's all be responsible that let's dispose our waste properly. Why? Let's take example. During my PhD, I work on different material sources, their effect on the soil, and then how about if you can combine with chemical fertilizer? And I discovered that this, we call it municipal waste. In Hausa, they call it bola. Some will even carry it, go and spread on the farm, thinking that it can contribute to the fertility, but it will just worsen the situation because it contains a lot of materials that cannot be decomposed even in 10, 20, even up to 50 years. Let's give, for example, for this attachment that our women use locally today or commonly today. You put it in the soil, it will take up to 50, 100 years, it will not decompose. And once decomposition has not taken place, there is no meaningful chemical or nutrient that will be released. And so even the microorganisms cannot even digest and decompose this material. And so what do we do is to deposit them or dispose them properly, either in a pit, dig a pit, bury them and forget about them, and cover them properly. So proper waste management is a way that we can prevent our soil from contamination. How about sustainable land use? Sustainable land use. Today, even farmers that use the land almost every day. Some will just use the soil to produce their food, and they will not care, they're not concerned about the sustainability of this soil. Let's give, for example, when I came to Abuja a few years ago, I saw the indigents planting corn, that is guinea corn, and maize on the same plot of land. Planting the corn, the maize, around April, May, some of them they are planted already. Then around June, July, they will intercrop with what? With guinea corn. And that one is like putting heavy load on a child. He has heavy load on his head, and then he's carrying another one in his hand. You will kill that child. And so proper use of the land use system, land use practices can damage the soil and can introduce a lot of what? Unnecessary contaminants into the soil. Look at the use of agrochemicals we said earlier. The volume and the concentration is not being taken into cognizance. Once this chemical can prevent or can reduce weeds, they can use it anyhow. And so these agrochemicals today are being misused by even farmers themselves. And so we have to encourage the sustainable farming practices and reduce the use of pesticides and fertilizer. We all know that even chemical fertilizer, which we call inorganic fertilizer, we call it mineral fertilizer, they contribute a lot of what? Negative effects on the soil. They can even cause soil acidity, nutrient depletion, because since they are being applied to the soil in a very available mineralized form, the soil, the plant will exhaust everything. Let's give an example like urea. Urea has to be applied every year in, year out. Why? Because 100% will be utilized by that plant, particularly you plant maize, you plant rice. They will use this fertilizer 100%. You have to repeat it. And every year you repeat it, it will just reduce the fertility of that soil. So we have to look for proper use of land. This land, we can't do without it. We are part of the soil. Because after we spend our life on this earth, we are returning back. We are going back to this soil. So it is our responsibility to take care of this soil as we take care of our bodies, we take care of our homes, of our families. The soil should be taken care of properly so that its fertility and productivity can be sustained for a longer period. Apart from that, industrial emission control. Industrial emission. What do you mean by that? You go to industry, as we visited a few years ago, that's what we call byproducts. For example, these tiles we use to decorate our building, to put it on the floor, the shiny one or whatsoever, they are being produced from a soil, which we call kaolinite or kaolin. Kaolin is a soil that agriculturally is not fertile. Agriculturally is not productive. But that soil is very, very good for industry. It is that type of soil they are used to produce these tiles. It's only to polish it. But after separation, the byproduct, if it is not well disposed of, can cause pollution, can contaminate the soil and damage the soil. So industry should take control of how they dispose even for their byproducts. Somebody is saying that, look at America, highly advanced and industrialized nation. But do you know that we in Africa, we contribute to what will damage to the soil and the environment, particularly what we call ozone layer depletion. We release some gases, we call it greenhouse gases, like methane, carbon monoxide, nitrous oxide, nitrogen dioxide, and then the rest of them. This can pollute the environment, and mostly they are being emitted from industry. But in America, or in an advanced world, they have means of controlling this emission. Either some they put exhaust, and the exhaust they will put filter that can filter the air that will come out from the exhaust, which is not very applicable or being practiced in our environment. And so we have to know or to encourage this control of emission of all these necessary pollutant gases. Apart from that, we have to discourage illegal mining. Today, because of poverty, because of hardship, you go to many places, you enter this riverine area, you will see people digging. What you ask them, they will say they are looking for gold. But in the process, they are damaging the soil more than the income they get from this illegal mining. Few years ago, we have had what happened. Lead pollution killed hundreds of children in Zamfara, and then the rest of them. So we have to discourage illegal mining. This to promote the soil. Then we have to, another subtopic is the proper use of fertilizers and compost. All these ways are being taken in order to minimize the contaminants and then the contamination of our soil. So proper use of fertilizer and compost involves understanding their distinct roles and how they complement each other. There's what we call overdose. But because of the cost of fertilizers today, overdose is no more actually is a problem. But the improper use of the fertilizer, you go to market today, you will see even people selling fertilizer or mudu, exposing the fertilizer, particularly urea, to volatilization and then the rest of them. And so fertilizer should be used properly, whether it is organic or inorganic. We know fertilizer provide quick and readily available, and because of that, proper use of this fertilizer is necessary. Mineral fertilizers, we said earlier, can contaminate the soil through pH, either reduce the pH and cause acidity, can even affect even the soil structure, and even affect the population and the activities of microorganisms in the soil. And so we have to encourage proper use of this fertilizer. To use the fertilizer effectively, you have to consider the test. You have to test the soil. And that's why we have fertilizer requirement for each plant. Every plant has its level of fertilizer requirement. For example, when we take of maize, maize is a crop that has the highest fertilizer demand. But even this one depends on the variety. You have to know the variety of the maize you planted, and then you have to know even the fertility status of that soil. Fertilizer will never be applied without testing the soil. Does the soil need this plant, this fertilizer, and how much? Fertilizer application varies. Particularly, let's move from here to the north. We are in the center in Abuja, central part of Nigeria. When you move northward, fertilizer application rate increases. Why? Because of low and poor vegetation, which led to what? Very low level of organic matter. And because of that, the fertility status is low. And because of that, as you move northward, the amount of fertilizer required increases. You are in Abuja, you move southward or you move westward to the south, particularly the western part of Nigeria, fertilizer application rate and amount decreases. Why? Because of the thick populated vegetation, which contribute to high level of organic matter. And so you cannot apply fertilizer generally or commonly everywhere, but from region to region, depend on the vegetation, then you have to know either to increase the quantity or to reduce the quantity. Apart from that, every plant has a different fertilizer requirement. If you are going to plant legumes, either groundnut or cowpea, and you start applying fertilizer, particularly nitrogenous fertilizer, like urea, people will laugh at you. It doesn't. Maybe if the soil is poor, then you can apply small, what we call as nitrogen starter to start. If not, leguminous plants, they produce their own nitrogen by their roots. And so fertilizer requirements and application is farmers have to be aware that proper use of fertilizer is very, very necessary. To use them effectively, you have to consider the test. Test the soil. If you test the soil, you know the fertility status. How much is the level of nitrogen in that soil? How much of organic matter in that soil? How much is potassium and all other necessary, what is the CEC? Then you consider, look at the pH, particularly soil pH, which is the representative of the acidity and alkalinity of a soil. If you know that, can tell you a lot, can interpret a lot about that soil. And so never apply fertilizer without testing or knowing the fertility status of the soil. If not, let me give you an example. A few years ago, I had a friend in the Mambila Plateau. There's a place we call Nguroje. There's a place we call Kiembu. In that place is a mountainous vegetation, high amount of rainfall and low temperature. Sometimes even snow do fall than the rest of them. And this, my friend, was a researcher anyway. He planted maize, and then after 2-3 weeks, he applied urea. He applied even NPK. It could not do anything. So he called my attention and said, look at the problem. look at my farm, and I applied this thing, there's no result, there's no response. I said, so you are a researcher, you yourself now. Have you tested the pH of that soil? She said, no. I said, okay. If to test the pH and then other soil properties is very difficult, just get organic matter, get cow dung, and apply to that maize, and you will see it will respond. And that's how this was able to correct that problem. Why? Because of low pH. So when you apply fertilizer on low pH soil, you will not see response. So instead of using fertilizer, correct the pH of that soil. And so fertilizer efficiency is being affected by some soil properties or particularly chemical properties like pH and then the rest of them. And so you have to understand also the type of fertilizer, as you said earlier. If it is organic matter, compost, what do we mean by compost? Compost is an organic type of fertilizer, either initially prepared, intentionally prepared, or accidentally prepared. Compost is different from ordinary organic matter. Organic matter is naturally put on the soil, deposit on the soil, either from plants or from animals. But compost are sometimes intentionally prepared, but all they are in organic form. And so sometimes, instead of wasting much money on chemical fertilizer, compost and other organic materials will do better. In my research, as I said a few years ago in my PhD, I combined these organic materials with low rate, let's say NPK. The crop, maize, either hybrid or local variety. The one I used was a hybrid and required a lot of fertilizer. And so how are you going to get 200 bags if you have 2 hectares, if you have 10 hectares? What is there is that you reduce the quantity of inorganic fertilizer, reduce the quantity of organic, either compost or ordinary farmyard manure. You apply, it will give you optimum yield or even higher yield. More if you apply high content of a single either chemical or organic fertilizer. And so we say combined effect. So wrong use of fertilizer can contaminate, pollute the soil. But today, when we talk of compost also, is very, very costly because it is prepared intentionally. Here in the university, we prepared by students, but if you talk, you have a larger plot of land, 10 hectares, 20 hectares. The only thing is to use the cow dung. In our places before I came here, people used to negotiate with the Fulani people that, okay, during the summer, that is during the harvest, after harvest, the cow, the Fulani will go and settle on a plot of land throughout from December or November up to around March, April to May, and then they will move away. In that, at least reduce the quantity of even fertilizer. Some at least for 2-3 years, up to 5 years, they will not require any fertilizer, but only the farmyard manure deposited on that soil naturally by the moving of it by the settlers. And from there, during the rainy season, the owner of the farm will come and take over and cultivate. And they will be negotiating year after year with the Fulani people. And that's why it is a beautiful condition. How we are today, that we and the Fulani, like we are enemies. No, we are brothers, settle together whatsoever the difference is, understand one another, and then help one another, complement one another. As they give us meat, The byproduct also, either in form of farmyard manure, used to fertilize our soil, increasing the fertility, and even reduce the level of soil contamination as we talk about it. We talk about soil testing. It's very, very important. How do we test our soil? As we said earlier, you have to sample the soil, dress it very well, remove all the foreign materials like the roots of plants. By what? By grinding the soil, grind the soil, and then sieve it. In the lab, even here in our place, we have different size of sieves. Sieves differs in size. That is, we call diameter. And depends on the type of analysis you want to do. If you are carrying organic matter, you want to see the level of organic matter and nitrogen, you have to grind the soil very, very soft. But when you are testing for pH and others, at least you can even use the high watt or the low sieve the diameter. So it depends on what you want to look at from this soil. The sieves are graded. And so after you sieve your soil, pack them very well and take them to lab for what we call analysis. And this analysis can be, if you are looking at acidity level, we call it pH analysis. This one will give you the level of acidity and alkalinity of the soil. You are looking at different cations. We call it cation exchange capacity, CEC generally. That one, CEC is corresponding to the level of fertility status. The higher the CEC, the higher will be the level of fertility of that soil. So how about if you are looking at NPK status? You are looking at how much nitrogen there. You are looking at how much P, that is potassium, phosphorus, and then K, which is potassium. It has its own different method. And when you analyze, you interpret the soil. And sometimes you can use graph to interpret it. You can use different either polygon or the rest of them, or use of tables. And from there, you can know okay, sorry, there's little interruption here, but it's a go. So that is how, as we said also, you can combine this fertilizer with compost, combined effect, single effect, and you will see that combining them will even be more helpful and reducing the level of contamination. And so, as we are rounding up these lectures this afternoon, what is safe soil management, safe way, safe practices, activities that we carry out on the soil can affect our soils. And so we have to be responsible and carry out measures on the soil to reduce this level of contamination and prolong or sustain this soil, because we cannot do without it until when we leave or the life is gone out of us. We cannot do without soil. Soil is the most important resources, natural resources we have. Water is there in the soil. Animals is there living in the soil. We build our house on top of the soil. We get our food and other things from the soil. And so it is our own responsibility to take care of these naturally given resources so that we can use it day in, day out. After we leave, our children will also inherit the same soil, and the life continues all through. And so there's no life. In fact, one writer said, there's no soil, no life. Because if there's no soil, there will be no food. And when there's no food and water, there will be no life. And so, my good people, as we're rounding up this class for today, we are having it either tomorrow or Thursday again. But what I'm leaving you with is that soil is a naturally given resources, very important to engineers, to farmers, to even petroleum industries, because all our petroleum products are hidden inside the soil. And so whether we like it or not, let's respect this soil. Let's cherish it and let's adore it. And all our practices carried out on the soil, let's do it with care, with carefulness, so that this soil, we can use it up to the end of our lives. After that, we leave it for our children, and we will be more blessed. So at this time around, I want to give time for questions, contributions, and other ideas from the listeners. Thank you so much.
All right, thank you so much, Prof. This is too much. Again, our dear farmers, like we told you, yes, the quality and the caliber of the facilitators we are having. Come on now, let me see your digital hands and in the comment section, appreciate Prof for such an excellent session. Prof, thank you so much. And again, our farmers want to drown Prof with questions here.
Yes, okay.
I'm looking at the question and I'm even surprised. I don't even know where to start right now. But
Can they talk?
Okay, they will though, but they will. But let me just read through some. Then we'll give an opportunity for some of them to come and.
Okay, sir.
So this question is from Kinde Do. Question number 1 says, "What is the average cost of soil testing? At what size? At what farm size will be economically viable to carry out soil testing before cultivation?"
Okay, another one.
Okay, so how do we
I should answer this one by one.
All right, so yeah, if that's fine for you, any of it goes with, sir. If you want more, I can. So.
Okay. For this one, the general manager, actually, what make people to run away from soil and then the test is the cost. Many farmers, I could still remember a few years ago, somebody invited me as a consultant to the farm, where we guided the person how the sample is going to be sampled. Just as we say, there's random sampling, there's diagonal, and even different method of even sampling the soil. And we guided the farmer very, very well. We didn't even give proper course. But you know that after that lecture, the person could not call us up to today again. Why? Because of the cost implication. Actually, soil test is one of the most costly examination or test, even more than even blood test sometimes. So the cost depends. Number one, because of high cost of chemical. The chemicals that we call reagents, actually they are costly. Even here in Abuja, you can only get them in Suleja. And when you said the university, even how many universities that you can go today, and get these reagents. So some of them, at least, we have to contribute and buy. Like students of postgraduate, they have to contribute and buy. And because of that, really, it makes the cost and then the test sometimes, can we say, it is not possible, it is not impossible, it is possible, but many farmers are running away from this test. And that's why, let me tell you, Victor, when you look at our roads, from University campus to Gogolada, there is a Fadama land before, but today it is a road. How did they do it? They have to test the soil. Whether you want to build, whether you want to construct road or whatsoever, you have to test the soil. You want to plant, you have to test it. But really, it is costly. Number one, they will charge you. They will charge you the lab technologies. They will charge you depend on the element you want. For example, if you are looking for heavy metals, which we call micronutrients, you are looking at the content of zinc, copper, manganese, or heavy metals like lead and mercury and the rest of them. You have to do, first step, you have to extract these samples. And it is this solution that you have to subject it to AS. So because of this long procedure, many people are dodging it. It is costly, really. But when you do it, you will save a lot of even human lives. Because without testing, you can't know the appropriate fertilizer to apply, and then even the amount to apply, and then even when to apply. And so the testing is necessary, but to be candid, it is a little bit expensive. Yet, you still run it. Here in the university, we do some here, some we have to take it to IITA in Ibadan for this analysis. But they are very, very feasible and possible. We have laboratory all over in Kaduna, even in Cuba, and then the rest of them. Thank you, sir.
All right. So thank you very much, Prof. And before we give other people opportunity to come and ask their questions, because we can't actually exhaust all these questions, so we'll just give a few people opportunity to come and ask. But I will read this. This is from Jibril Alhaji. He said, "How do we maximize the use of organic fertilizer, given that it is not in abundant supply?" Then Hassan Latif says, "What policy or support systems are in place to promote safe soil management in this region, and how can some soil testing be conducted?"
Okay, number 3, you say the practices or soil management practices.
What are the policies?
Okay, question number 3 again.
Okay, so how often should soil testing be conducted, and what policies and support systems are in place to promote soil safe management practices?
Okay, sir. Number 1, when we talk of organic fertilizer, there are many. Farmyard manure is the byproduct from animal farm. And today, almost every household is raising chickens and keeping animals. What do we use these for? Apart from producing meat and income, their byproduct, that is the excreta, is very, very important. Like a bag of, what do they call it? This poultry manure is equivalent to almost half bag of urea. And so we can produce. We cannot say that organic manure is costly or is scarce. No, we produce animal everywhere. And as I said, in my place, before I came here, they used to agree with what? With Fulani go and put your cattle during the summer. That is from December to April. Fulani people will settle on that land. And then May, June, negotiation, they will negotiate, okay, you can move out from this place so that I can plant. It's a negotiation, you can negotiate. Or even we ourselves, many places, many families keep animal today, either poultry, either sheep and goat, and a cow. This feces, or what we call the excreta, is what we turn it to be what? Farm yard manure. And so organic fertilizer, apart from that, there are organic fertilizer today available even in the market, either in liquid form. So, and they are much better than the chemical fertilizers, because the chemical fertilizer can cause acidity, can cause nutrient depletion, because every year you have to use them. So that is that. So because of the cost, we cannot compare the cost of inorganic fertilizer. How much is a bag of urea now? Last year we bought, was it about 30-something thousand? I don't know whether it is up to 50,000. But you can still get organic farm-yard manure lower than that. Where the cost of the two, we can say that organic manure is still more affordable still than some. Even you can go there and say, come and pack without even paying one kobo. Apart from that, we say, how frequent is soil test? Well, the result of a soil test, you can use it for 5 years. You can use the result. If you carry out good test before soil the properties can change, at least will be up to 5 years. 2 to 3 years, you can still use that result will be relevant.
Oh wow. Ladies and gentlemen, did you hear that? That's so profound. Okay, so it can save you a lot. So in fact, it's just down on me because we as ginger farmers in Kaduna, if we had been doing soil testing, we wouldn't have suffered what we suffered 20 years back. And you heard, so you can do proper soil
there are
testing.
labs very close to you in Kaduna. Commercial labs in Kaduna, laboratory that at least we used to even go for tests.
All right, thank you very much, Prof. So quickly, we are going to unmute Isaac Ekoja to ask his question. And please, first of all, introduce yourself and tell us where you are speaking from. Isaac Ikoja.
Okay, you're welcome, Isaac. Hello, Isaac.
Good evening, Prof.
Good evening, sir. How are you?
I'm fine. You can hear me, sir?
I can hear you very well.
Yes, my name is Isaac Ekoja. I'm speaking from Owerri, Igbo State.
Okay, you're welcome.
Yes, I want to thank you, Prof, for this lecture, and I think it's one of the very important lectures in most of this we've been taking.
Yeah.
But I just want to ask a question. My number one question is there any possibility that organic fertilizer like animal manure, especially droppings or cow dung, would have something like heavy metals? That is one. Then number two, again, I look at it, nitrogen, especially this urea. From our elementary understanding, they say the end use of it is nitrate. And both nitrogen coming in form of synthetic fertilizer or in organic fertilizer, all nitrates. Why is it that the one of synthetic now is now considered to be detrimental to soil? That is my questions. And then the final question is that if you are going to do collection of soil sample, are there any precautions to take before you collect soil sample from the field? Thank you, sir.
Is there any
precautions to take while collecting sample from the field?
Thank you, sir. So your number one is okay. The method you say heavy metals. Heavy
Yes,
metals
I
in
say
cow dung. Very good. Hello, are you hearing me?
yes, I can hear you, sir.
Okay. Cow dung or organic materials, they have all the nutrients, including heavy metals. But heavy metals, we call them essential micronutrients, like zinc, like copper, like manganese, like molybdenum, and the rest of them. These are essential micronutrients. Not all of them are metals, but they are essential micronutrients. And all of them are there in the cow dung, but very difficult to get them at toxic level. Are you getting me?
Yes, sir.
Very difficult to get them at toxic level. But there are inside as part and parcel, apart from NPK, calcium are there, and the other like chlorine and then the rest. But all it's very, very difficult to get this element at toxic level. Why? Because during their decomposition, organic matter or cow dung, when you apply to the soil, it has to pass a lot of biochemical processes. First stage of decomposition. After decompose, that's the work of another microorganism. Then after decomposition, another organism, what we call nitrobacter, will take over and then chew it again and mineralize this organic element to turn it into inorganic or available form. So during this process, two or dual processes or long processes, whatsoever that is high, at least the micronutrients will digest and then release it. And so it is very, very difficult for you to get toxic level of nutrients in organic manure, particularly cow dung. Have I answered your question?
Yes, sir. Thank you.
But they are necessary, they are not at toxic level. You talk of nitrogen. Nitrogen, all nitrogenous fertilizer, I didn't that I have time to teach you about fertilizer. All nitrogenous fertilizer are produced from ammonia. Ammonia is a gas that is being produced what? By tapping the atmospheric nitrogen and hydrogen together. When you tap it, it passes through reaction, which we call Haber process. Haber was a scientist in Germany who introduces or who founded the production of ammonia in a larger form. So if you produce this ammonia, then you can use it to produce nitrogenous fertilizer. Urea, for example, it is not only nitrate. Urea and other nitrogenous fertilizer supplies nitrogen to the plant in ammonia in an ammonium form. That is NH4 positive on the top, and then nitrate. But the most available form is that nitrate. So nitrate can easily be taken by crop, but if it is ammonium form, if the fertilizer is applied during the dry season, that's why you cannot apply nitrogenous fertilizer when the soil is dry. Why? Because the ammonium aspects of it after conversion will be volatilized into the air in form of ammonia gas and will escape. So nitrogenous fertilizer is always applied when the soil is moist. What happened to my hello, Victor?
You clearly,
Yes,
sir.
sir. We are here, sir. We can hear you.
Oh, okay, you can still hear me.
Yes,
Yes,
sir.
sir. Clear.
Okay. So nitrogenous fertilizer is not always a nitrate. Nitrogen can also be given to plants in form of ammonium. So it is this ammonium form that when it is being exposed to air or to high temperature, it can be converted into ammonia gas and escape into the air. Though even the nitrate also, under severe condition, nitrate can be converted into nitrous oxide, and then the rest of them all can escape. And that's why urea fertilizer or nitrogenous fertilizer always needed to be applied on a moist soil for easy conversion and utilization by the plants. Then you talk of your third question is prevention.
Precautions to take while collecting soil sample.
Very good. Precaution to take. Sampling soil is just like walking in the lab. Going to the field, number one, at least you have to, the precaution is number one, you have to cover yourself very well. Possibly this, what do they call it? Face mask. You cover your nose very well. Use your hand gloves and a cloth that at least will not, the pollution will not even affect your body. So there are guidelines, there are precautions, and then there are procedures for even proper sampling of soil. And you will not use dangerous material. Actually, sometimes there is soil auger. This soil auger can sample the soil without damaging the soil and without causing injury to even the user. And so there are ways, just as going to the lab or going to the hospital, there are procedures that at least you have to take before going into sampling your soil. But you have to cover your nose very well and then put hand gloves so that this contamination, because you don't know this soil, some of them are contaminated, particularly we talk of contaminated soil. You are coming from Owerri, you are from a oil producing area, you are from Delta region. And so your soil is even, can be even more polluted than we here in Abuja. And fetching it or getting it before you take to the lab, you have to be very careful and to protect yourself from injury and from other inhaling the dangerous elements that we mentioned above. Thank you. Are you okay?
All right. So, Mr.
Thank you,
Isaac,
sir.
you'll be the first to appreciate Prof on behalf of your fellow farmers, because Prof has taken a good ample time to answer your question. So please do that quickly.
I'm grateful.
Well done. Are you okay?
I'm okay, sir, with your answer, sir.
Okay,
All right. So
thank you.
just on behalf of your colleagues, quickly just appreciate Prof, just formally.
It's okay. I want to really first of all thank God for this opportunity and to thank you people for this platform. It's actually a good platform for that have helped to reshaping our knowledge and also understanding of going into farming. Prof, we want to appreciate you for sparing your time and for being patient to answer questions and teaching us extensively some of the things that we need to know, some that we don't even know. I want to pray that you will always be there for us anytime we still need you, especially after now when I need to reach out to you. We thank you so much for. God bless you, sir.
Well, you are welcome. Thank you so much.
All right. So
thank you, sir.
What we do is because we are out of time, we'll give two people an opportunity to just just one question each to Prof, and then the group will be open to everyone so that you drop your questions, and then we'll send it to Prof. Prof will give us an answer, then we'll share it in the group. That's what we'll do, so that because we are behind schedule. But Prof, you can hear me, right?
Yes, I'm still around.
Please, okay. So please, we are going to give just two people opportunity to ask one question each. Can you unmute Jibril Abdul Hamid?
Hello? Hello,
Mr.
manager.
Jibril.
Hello, can you hear me?
I can
Yes,
hear
yes,
you
yes.
very well.
Okay, good evening, Prof.
Good evening, sir.
Thank you very much for the wonderful presentation. Indeed, we enjoyed the knowledge you've impacted on us, and inshallah, we'll put it to use. So,
Thank you.
my question is this. I read somewhere that,
Where are you calling, where are you calling us from? Also, can you just tell us? Thank you.
yeah, I'm calling you from Lokoja, Kogi State.
Local,
All right.
yeah?
Yeah,
Yeah,
Kogi
welcome.
State.
Welcome.
Okay, sir. So, I read somewhere that, Moringa tree
Mm.
has this ability to improve soil nutrient. I don't know how true is it. So I want you to comment on that, Prof, please.
All right. Thank you very much.
Yes, moringa tree, is it for planting on the soil? Hello? Hello? We are talking of planting of moringa. Hello, I can't hear you again. Hello, manager.
So I don't know. I think what he's referring to is
Well,
that he
just as we have said, what we are looking at removing contaminants. I believe that this moringa can even be used apart from banana. You know, if we talk of some of these foreign crop that is planting in Europe and then this one, will be deceiving us. But locally, we know moringa, at least from the root to the leaves to even the seed, all of them, they are medicinal. As such, planting moringa can even remove or reduce contaminants. And once you remove the contaminants, you are restoring back the soil fertility status of the soil. So moringa, though actually I have not read that, thank God at least you have revealed it, but we can still go into more research. But I believe that moringa can even be used at least for to reduce or removing even contamination, thereby restoring back the soil health and soil fertility status. Thank you.
all right. So quickly, Justice Cletus, can you please unmute and
Okay, good evening, Prof, and good evening, our host. My name is Justice Cletus from Kaduna. It has actually been a wonderful presentation so far. My question to Prof is, please, we are dealing with most of our local farmers within our area here, predominantly southern Kaduna, and ability for them to really dictate soil pH locally. There's actually been a challenge. So I don't know whether Prof can help us. A possible way that locally we can identify soil pH in our farms. Thank you very much.
Very good. Soil properties, both physical and chemical properties and biological, can be determined on the field. But if you want the real thing, you know, we have been talking about equivalent. For example, even the government has been fighting, or people have been fighting, that HND and degree is equal. HND is equivalent to degree. But when you talk of this one is equivalent, it's not the real thing. That means there must be some setback. And so when we talk of testing the soil on the field, can give you like a guess. Yeah, it can give, you can predict. But if you want to do the real thing, you bring it to the lab. For example, if you want to test soil pH specifically, soil pH can be tested. When we talk of litmus paper, I don't know whether you ever had during our secondary school soil chemistry. There's papers that sometimes it is local in the market. It is bluish in color. One that is red, one that is blue. you can dissolve your soil and then drop that paper into it. When that blue paper turns to red, that soil is acidic. When the red paper turns into blue, but that if it is not possible for you to get that, even by looking at the soil color, when you see soil is reddish in color, definitely you will know that that soil is acidic. Why? Because leaching has taken place on that soil, thereby removing all the what? The basic cations like calcium, like magnesium, potassium, and sodium, leaving the stubborn like iron, either ferric or ferrous iron and aluminium oxide, and then the rest of them. And that's why most of the soil in the southeast, if you have ever been to southeast from Enugu downward, their surface soil is always reddish in color. Why? Because of excess erosion, thereby removing what? And then because of high moisture, leaching, and then surface runoff, removing all the basic cations. And so when you see the surface soil reddish in color, definitely you will know that this soil is acidic in nature. But when you see the soil black, you will say, okay, this soil is high in organic manure. And mostly, at least, their soil, the pH is higher than that. So by looking at that, for example, if you see you want to test the soil texture, whether this soil is sandy or loamy or so, you rub it among your fingers, and we know that from even primary school, you can wet the soil again and then start making into shapes. Sandy soil, you cannot even form either cycle or whatsoever, even a ball out of it. But loamy soil, you can form a ball, but not a ring. But clay soil, you can form any shape, even up to ring, and then the rest of them. So organic matter also can be identified. The level of organic matter can be identified also physically before you go to the farmer. When farmer takes you to his farm and you go there, you can judge, this your soil is fertile. Even the presence of what? Soil animals, like this, what do they call it? This earthworm cast. If you see a fertile soil, you will see the earthworm cast. That is the cast that their physics very big. When you dig, you will see some of these worms up to even your finger, as big as anything. And so even the population and the size of even farm and the soil animals can even indicate the level of fertility of that soil. So acidity can be assessed physically, looking at the soil color, looking at even the presence of soil animals. When the soil is acidic, definitely you will see soil animals will never habitate that place, or there will be few, or even there will be lean even in size, like earthworm and then the rest of them. So to avoid even all this, most of these soil properties, if it is soil structure, you can judge the structure of the soil, whether this soil is well structured or poorly structured. You take a bulk of it and throw it on the ground. You will see that a soil with a very strong structure, not all of them will be crumbled into pieces. So soil fertility test and soil, both physical and chemical properties of the soil, can be judged physically before you go to the lab. But if you want to get the real thing, if you want to get the amount, definitely the amount of pH, is it 6.1, 6.5, or 5, or below 6, or is it 0.7 point something? The soil is neutral. You have to be patient and take it to the lab. But at random, because you can judge the soil physically also, you can guess, it will give you approximate, but not the real thing. Thank you.
Oh, thank you very much, Prof. Thank you very much, Prof. So, guys, we are far behind schedule, so sorry, please. The last thing we'll do is Please, I've been looking through through the names of the people who raised their hands. I didn't see a female, but I just saw one just now. That's Juliet Ogechimaduka. Please do us a favor and just come and appreciate Prof. And tell us where you're joining us from and appreciate Prof on behalf of your colleagues before we close the day. Thank you very much. You can unmute, Juliet.
Hello, Prof.
Okay, good
Hello.
evening, Juliet.
Good evening, Prof.
How are you?
I'm fine, Prof. I really enjoy your lecture this evening.
Okay.
I want to thank you on behalf of other learners. You've done so well for us. And I pray that what we have learned, we will use it and it will really work for us. We will use it to also teach others that really want to learn, because a lot of people, a lot of farmers in the rural areas, they are really lacking this knowledge. I pray God will help us so that we impart this, what we have learned today, to them too. Thank you very much, sir.
Thank you so much.
I asked a question. I don't know. I asked a question.
Okay.
Because where I live, so people around here, they say they don't put fertilizer. That the fertilizer normally spoil the soil nutrients. So I don't know how true that is.
Okay, they don't use fertilizer.
Yes, they don't use. This area, I'm from Imo State.
Is it the Gwari people, ba?
No, I'm from Imo State.
Is it the
State.
indigenous? Okay.
Yes,
In your
yes,
place, number one, as we have said, if you don't use a mineral fertilizer, yes, do they have availability of organic fertilizer like farmyard manure? Apart from that, what is the status of the soil? You are from the southeast. At least you have high vegetation. When the place is well vegetated, trees are there. For example, when you go to the southwest, between Ibadan and Lagos, you know the forest there, you cannot even see a distance of 10 feet or the rest. That one is when you cut small, using fertilizer is not necessary. And so if your soil is highly fertile, why should you even waste money on inorganic fertilizer? It is not. I visited a few years ago. I took my final year student to what is this place in between Anambra and Enugu, Oji River. You know Oji River? Hello, Juliet. You can't hear me again. Okay. Manager.
I can hear you. Okay.
Okay, you can hear me. Okay.
Yes, sir.
There's one farm we visited with my final year in Oji River.
Okay.
That is what we call organic farming. Organic farming, at least today, they don't use any chemical, not ordinary fertilizer, even pesticide. Everything they control their weeds organically, they control their pests organically, and even the grasses, they weed. They don't even use chemical for weed control. They use hand weeding. And then the grass, they will turn it into what we call compost. We discussed of compost today. They turn it into compost and use it as fertilizer. So there are places of organic farming, organic farmers that don't even use chemical at all, not only fertilizer, even pesticides and herbicide, they don't use it. But do you know that the plant, if you see their tomato, actually as beautiful as anything. But any crop that is produced organically, the cost is higher than the one that is produced from chemical fertilizer and other chemicals. So it is possible very well, particularly in the southeast. The organic matter is high, and then the rest of them. So it is not necessary. And that's why even everywhere, that's why I told you, even my PhD, I use how can we reduce the use of this inorganic fertilizer. Okay, if you cannot do without it completely, then you combine with small quantity of chemical and small quantity of of organic, you mix them together. will give you optimum yield. And so the use of, even we soil scientists, we are discouraging the use of chemical fertilizer because of its poor attitude on the soil. It increased soil pH, like your area at least southeast is highly acidic. That's why your soil is the reddish in color. And when you use some of this inorganic fertilizer again, at least the soil will turn to be more acidic. And so we are asked to be discouraged or to reduce the amount of inorganic fertilizer use. And if it is possible, if it is affordable, then organic farming is better, is more better, produce more healthy food, and even in bigger quantity and even size, particularly fruits and vegetables. Thank you.
Oh, you're
All right,
welcome,
thank
sir.
you. Thank you very much, Prof. Thank you very much. And to all our participants, thank you. We can see that you guys are still here. And also to our participants following us on YouTube, we can see you. Well done, well done. This is great. Thank you very much. So because we are behind schedule already, quickly, this is us at GSAI. You know, as a non-governmental organization, we want to ensure that our farmers practice sustainably and become profitable. That is why you are getting these premium lectures from, of course, excellent facilitators like this. Prof is coming again on Saturday, so brace yourself for another excellent session. And to all our partners, sorry, Mr. Black, do we have any of our partners available here that we can spotlight? If there's none, I think we are far behind schedule right now, and so we can just head up and prepare for Saturday.
Okay, thank you so much. There are no partners, but I'd like to say a few things before we close for the day. Good evening, participants. Good evening, Prof. Prof, thank you so much for a wonderful session. That has been very beautiful. I know the many challenges that came around to having today, but I want to really appreciate you for stepping up and coming to help the younger generation to improve sustainable farming in Nigeria and in Africa. Yes, let me just make a few announcements. Victor, you will continue the announcement, but I just want to say three things. First and foremost is to the participants. There are some participants that have come into my DM and into the DM of other GSAI staff to talk about the commitment and some other things that they think are the major component of this training. I want to clearly state that this training is not a competition. I have students that are coming in to talk about, some people that we put the attendance sheet in the WhatsApp group. What will happen to those that did not attend but fill the form? We have people that are coming to say, I have been attending since, and all of us make it as a competition. There are criteria, there are modus operandi for selecting whoever we are going to be selecting to be beneficiaries of maybe the attendance of the Nigerian Farmers Town Hall Summit in Abuja, and whatever benefits that will come in. Other partners will be coming in. I'm sure from next week we'll have partners that will be coming in to also give out some benefits. But this is not a competition. The core aim of this training, which we have made very free, participation in this training is free. None of you have paid a dime to attend this class. The training material of professor will be shared to you. The core aim of this training is to pass knowledge. So if you're coming to this training to come and compete on who is the best participant, you are attending it in the wrong frame of mind. Come for this training and do not bother about who is the best participant. Be bothered about you getting the knowledge that you need to get. That is primarily the aim of this training, how you can produce healthier and safer foods for our country. And in the process, you are able to produce both for local consumption and for export consumption. That is very, very key. So please, I would like you to change your mindset. There are benefits that will come. Those benefits will come, and then there will be a clearly spelled out modus operandi for different people to benefit from it. But for the meantime, please participate to get knowledge. That is one. Secondly, as part of your commitment, as part of your appreciation to GSAI for this program, we will, and this is very optional, if you can make a testimonial video, just very few, less than 1 minute video, thanking GSAI for the opportunity and talking of what you have learned, 1 or 2 things you have learned since the program started. Now, this video should not be made in your house. It must be made in the background of a farm. So this video is requested from only farmers. You have to stay, your background has to be a farm, either a beginning farm, either a crop farm or a livestock farm. And then do your video as a farmer, thanking GSAI for teaching you and training you on how to achieve farm food safety. So those that can send in their videos between today and Wednesday next week will be featured on our social media. And then these are some of the ways we will also be judging committed and appreciative members. Then thirdly, so yes, please send in your videos. You don't have to do plenty editing. You can use your phone, make sure there's good lighting, and then of course, your background has to be a farm. We will not accept videos that are coming from offices, videos that are coming from houses. Your background has to be a farm because this training is for farmers. So finally, thirdly, we are also watching and appreciating and recognizing those that have engaged us on social media. Quite a number of people have made posts and have tagged GSAI. They've tagged GSAI, talking about the project, talking about the training, and also talking about their experience. That is also welcome. Those are people that we also recognize as being appreciative and being committed to the training, right? So, yeah, those are the 3 things I wanted to highlight. And of course, I will always continue mentioning, this is a free training. However, if you want to get the certificate at the end of this training, please, you will have to pay a subsidized fee of 5,000 Naira for your e-certificate. Now, that e-certificate will come with a barcode that is verifiable, and this certificate can be tendered to get a job, a supply contract in ShopRite, in any big institution that you have been trying to get a supply contract. By the time you tender this certificate, you can show them that you have the requisite knowledge to plant and to produce food according to their standard. This certificate can also be tendered as a proof of training when applying to get a export certification. This certificate can be applied. You can also tender this certificate to get a job as a safety trainer, as a farm food safety trainer. There are a whole lot of benefits you can get from doing this certificate, but if you are unable to get it, that is fine. It is very optional. The training, the knowledge, the training materials is given free of charge. And then, yes, like the moderator has mentioned, class will be holding. The next class is on Saturday, and we are lucky we'll be having Professor Wapa continue the next class. He will be teaching the next class, and he will also sharing materials with us. So I think with that, I want to thank all of you that have been committed today. We had almost 170 students and participants, and more is going to come. We are seriously talking with our partners. Information about the Nigerian Farmers Town Hall Summit will be dropped once it is ready. Information about the farm tour and so many other projects that are ongoing in complementary to this project. Remember, this project is being carried out in commemoration of World Food Safety Day. The World Food Safety Day is usually on the 7th of June, and we are doing this project to commemorate World Food Safety Day. So there are many other components that are coming as part of it. Please, if you have questions, ask the admins. Yes, for those of you that are still asking for, what do they call it, for code numbers, on this week we were unable to give you updates of your code numbers. So on the attendance form, that place that they are asking for code number, just put there NA. That's not applicable. NA, fill the form, put NA not applicable in that space for this week. We will accept it for this week. Hopefully before Saturday, we are able to update all the code assigned code numbers to those people that have filled their master sheets. You fill the master sheet only once, and if you have filled the master sheet, you wait, your code number will be assigned to you. So hopefully before Saturday, we are able to assign that. But today, as you're filling attendance sheet, in the place of a code number, just put there NA, not applicable. And then as we go on, we will resolve all those issues. Thank you so much. Moderator, please take over from here.
All right, good. Like he said again, all lecture materials are free. And so please, again, the subsidized rate for the certificate is 5,000, at least from now to the end of this virtual session. That's on the 27th of June. Anything after that it's going back to the normal price, which is 20,000 naira. So please keep that in mind. Okay, so ladies and gentlemen, beloved farmers, congratulations for staying tuned to this very time and learning extensively. God bless us all, and may what we learn be put to good use. Thank you very much. And Prof, again, we are grateful till we see again on Saturday. Thank you, everyone. Have a blessed day ahead. Cheers.
Thank you. Okay.
Please, the attendance is in the group chat. The attendance is in the group chat. You can check it.